Okay, so we found our critical numbers. We're ready for a sign chart. So step 3, sign chart. For my derivative, which was f prime of x equals 8x to the 5/3 over 3 minus 8 over 3x to the 1/3. That was my derivative. So I have critical numbers of plus and minus 1 and 0. So negative infinity to negative 1. Negative 1 to 0, 0 to 1, 1 to infinity. And I mentioned this earlier. I like to make honest-to-goodness charts. That's just the way I learned. It's what makes sense to me. Some teachers draw number lines here. There are different ways, slightly different ways of expressing this information, but all the basics are there. Those numbers are there. Then somehow you determine the positive and negative. I like doing the test value thing. So test value, any number in each one of those intervals. So negative 2, negative 0.5, 0.5, 2. And decimals here are perfectly okay because those aren't going to be the answer. The answers are up here, honestly. Just got to clarify those answers a little bit more. And then we plug into the derivative. And you can use your calculator. It's fine. I'm going to use my calculator. So 8x to the 5/3 divided by 3, and then it was minus 8 divided by 3x to the 1/3. So I've put my entire derivative in there using very careful typing. 8x to the 5/3. I have an older calculator, so the exponent in parentheses divided by 3. Then 8 divided by, and then the entire denominator in parentheses, 3x to the 1/3. Then you can quit. And then it was vars. Arrow over to y vars. Function, and then we put it in 1. And then put your number in. I have negative 2. Hit enter, and that comes out to be negative. Again, the key sequence. Vars. Arrow over to y vars. Then it's a function, and I typed it into y1. Then you put in the number that you want. Parentheses, negative 0.5. So it really is saying do y1 of 0.5. I get that answer. It's going to be positive. And then we're going to hope that this process works, that you should be able to hit second and enter. And that should give you your previous line, and then just go back and edit it. This time I want plus 0.5. So edit it, hit enter. That comes out to be negative. And then one more time, second and enter. Edit it to what you want. I want that to say 2. And that comes out to be positive. You can do whatever you need to do to get those signs. Do it by hand, do it by, whatever. Just get those signs. And so that tells me that f of x is decreasing, increasing, decreasing, and increasing. A negative derivative means we're increasing. A positive derivative means we're decreasing. Then just summarizing here, increasing on negative 1 to 0, 1 to infinity, decreasing on negative infinity to negative 1, and 0 to 1. Then as far as local maxes and mins, here my derivative changed from negative to positive, or my function changed from decreasing to increasing. So I had to hit a minimum there. So at x equal negative 1, with y equal f of negative 1, y coordinates, always the original function. And plugging into the original function, so that's going to be negative 1, 8 to the 3 halves minus 4 times negative 1 to the 2/3. Can she do it in her head a little bit? That's going to be negative 1 minus 4 times 1 for negative 5, we hope. And so negative 1, negative 5 is going to be a local minimum at x equal 0. So I go and look at my chart. F prime changed from positive to negative, or the function changed from increasing to decreasing. Whether my function changes from positive to negative, or my function changes from decreasing to increasing, both of those tell me that I must have a local max. So x equals 0 with y equal f of 0. Again, y coordinates always the original function. And so I'm going to get 0 cubed minus 4 times, or not 0 cubed, 0 to the 8/3 minus 4 times 0 to the 2/3 gives me 0. So I'm going to have the point 0, 0 is a local maximum. And then finally, at x equal 1, so I go and look to see what's happening at x equal 1. It changes from decreasing to increasing, or first derivative from negative to positive. In either case, that means I have a minimum. So x equal 1 with y equal f of 1, always the original function. And so I've got 1 to the 8/3 minus 4 times 1 to the 2/3. Well, that's going to be 1 minus 4 times 1, which is negative 3. Made a mistake up there. We'll go and fix that momentarily. I just noticed a mistake up there. We'll fix it momentarily. And so I've got 1, negative 3 is a local minimum. Now going back and changing this, because I made a mistake here, negative 1 to the 8/3 would be positive 1. And so this up here is going to be negative 3. I changed the mistake when I noticed it, but we're about to check it. And when we check it, we would have caught that mistake as well, but I made a sign error right there. So that was supposed to be 1 minus 4 times 1, which is negative 3. And so there are the answers. There are no endpoints to check here, but now we're actually going to check it. So I'm going to put my original function in there. And it doesn't matter if you do where we multiplied it out or not. I'm going to put the multiplied out one in there. X to the 8/3 minus 4x to the minus 4x to the 2/3. I got to really remember to put some new batteries in this thing. Then give it good numbers. Yes, you can hit Zoom 6, but all the important numbers are here. The important x values were negative 1, 0, and 1. Those were the only important x values. The important y values were 0 and negative 3. So concentrate on the important numbers. I'm going to go a little bit further, but there's no point in going from negative 10 to 10 because the important x values were negative 1 to 1. So I'm just going to go a little bit further. I'm going to go negative 3 to 3. I'll go ahead and count it by ones. The y values were negative 3 to 0 were the important y values. So I'm going to go maybe negative 5 to 2. Use the important numbers. Zoom in on the important numbers. My important x's were right here. Negative 1, 0, and 1. My important y's, you can see off to the side here. Negative 3, 0, and 3. No point in going from negative 10 to 10. Then hit graph. And it's thinking about it. Takes a long time to calculate all those 2/3 and 8/3 things. and then it should check our work. It should match our work. So our chart said decreasing, increasing, decreasing, increasing. Decrease, increase, decrease, increase. Look at the graph. Decrease, increase, decrease, increase. It matches that. We said at 1 and -1 we should have local minimums. Trace, -1. Indeed, it goes to that local minimum, and indeed the y-coordinate is -3. Check the one at 1, so put in 1, enter. It goes to 1, -3. We set a local max at 0, so put in 0, enter, 0, 0. And so it absolutely checks, so we know we are right. And it also checks another thing for us. Then again, I can just bring this up. That x equals 0 came from the derivative not existing. Graphically, when derivatives do not exist, you've hit a corner point cusp, vertical tangent, or discontinuity. Corner point or cusp, at 0, we have a corner point. So these things will absolutely check. And like I've said before, you got a few minutes at the end of a test or quiz or whatever, check these things. It might allow you to find a silly little mistake. And if you can't find the silly little mistake, you find out that you're wrong, but you can't find the mistake, you write me a note saying, I know this is wrong, and you'll get more partial credit that way. And then the times when it checks, well, then you know that you are right. And that is the conclusion of this problem and this section.